Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Herb, I want to try to take your picture here, if I may. Did you hear what that camera said? I'm going to do it one more time, just so the audience can hear this. Too dark, use flash. I don't really want to take your picture, by the way, Herb. I just wanted to use this camera, this Minolta camera here, as an example of the increasing use of speech in solid-state devices. For example, another one, I'm sure a lot of kids are familiar with this TI Speak and Spell.
Hello. Spelling level A. Press go to begin. Press enter to check your answers.
It's amazing, isn't it? We're talking about speech synthesis and a couple other speech subjects today on Computer Chronicles. Herb, and what I want to ask you to begin with is, let's take this camera for an example. It was kind of cute that it talked to me and said, use a flash, etc. But it didn't have to do that. A little blinking red light works in most other cameras. Is the use of speech a gimmick, a kind of marketing toy, or are there really useful applications for speech in computers?
Well, I'm sure we'll hear a lot about that today from our guest, Stuart. But I would observe that I find myself not really paying much attention to the warning lights on the dash on my car anymore, and yet I sure pay attention when it talks to me. And of course there are many voice terminals out there that can reach many more places than computer terminals can today. So I think there is something in the use of speech.
And by voice terminals, just telephones.
Telephones,
right.
Yes, right.
Okay, we're going to be talking not only about speech synthesis, but digital speech coding and speech recognition. And there's quite a bit of research going on in all these areas. Spoken language contains variables that can completely change the meaning of a word, depending on the context, the inflection, or the accent of the speaker. So for a computer to accurately analyze and reproduce speech, it needs to first break up the words into sound fragments and then reassemble them with natural speech emphasis. Synthesizing devices work either by digitally encoding entire messages or by phoneme synthesis, building words from a library of digitally stored fragments. Encoding speech into these fragments points out the primary importance of speech inflection and accentuation in determining how a phrase is pronounced.
Harry Potter. Computer.
The operator of this scanning electron microscope normally works in a totally darkened room because of the microscope's sensitivity to light. Faced with two different instruments, a microscope and a computer, the operator's hands and eyes are continually busy. But in this case, a microphone has replaced the computer's keyboard. The computer has been trained to respond to verbal commands encoded previously by the operator in his own voice.
Charge.
Machines that can understand and carry out verbal commands have been in development since the late 1960s. Today's applications are still limited. The breakthrough will come with the perfection of recent speech systems that feature context-sensitive rules and flexible models of human speech.
Language is more than just phonics.
Speech was our earliest form of civilized communication and is still our most common and for many purposes our most convenient. It would certainly be more convenient if we could verbally instruct a computer and then listen to its output. Well, the technology is rapidly being developed that will enable us to do these things. There are many examples of talking computers used by the telephone company for referral numbers, and many applications where the user calls a computer on the telephone and keys in certain passwords or other information, and is given bank or inventory balance information by computer voice response. The observation that many people are better talkers than listeners also applies to computers. As we discuss in a later segment, it is much easier to program a computer to generate passable speech than it is to understand our speech. The computer knows exactly what it wants to say and can generate an unambiguous, if somewhat stilted, series of words to say it. Understanding different word boundaries, dialects, indefinite references based on global knowledge, or nonverbal signals is very difficult for anyone, computers included. An example of word boundary problems occurs when I say Sam's spade. Do I mean a fictional detective or a man named Sam who received his paycheck? Thanks to cheap, high-performance hardware and computer techniques called artificial intelligence, which we will study later, computers can now understand a limited vocabulary or a larger vocabulary spoken by a limited number of people. We'll see some of these systems in our next segment. So let's get back to our program.
Joining us now is Carl Burney. Carl is Vice President for Corporate Development at Speech Plus. Speech Plus is involved in quite a bit of the new things in speech technology. Herb?
Let's start out, Carl, if you would, please, and tell us how does the computer synthesize speech?
Well, our machine takes any ASCII text, that's the way text information is stored in a computer, and converts that to intelligible speech. It first looks at the words, decides which phonemes are in those words. Phonemes are the basic elements of speech. It puts the phonemes together for the words. It massages them to make sure that they flow the way natural speech does, and then that's converted to a set of parameters for a speech synthesizer, which then produces speech.
When you say a phoneme, tell me more about it. You say that's the basic building block of speech. What is a phoneme, literally?
A phoneme is a short sound in speech. It's the fundamental element such that if a phoneme changes, it changes the meaning of a word. Phonemes are, you can roughly think of them as being vowels or fricative sounds, sounds, and a number of other sounds. There are roughly 38 to 45 phonemes in English, depending on which linguist you're talking to. And in other languages, there are roughly the same number.
Does your product cover all of the English language?
Yes, our product takes unrestricted text and converts it to English.
What size of a computer do you need to do that?
It's based on a commercially available 16-bit microcomputer chip.
When you say converts it to English, now suppose I were to type in French words.
It would attempt to pronounce them, but they probably wouldn't come out right because our phoneme models are for English and the phonemes in French are different.
With an English accent.
So this particular device is language dependent. It's
That's
programmable
correct.
in one particular
That's
language
correct.
with its particular set of
Also,
phonemes.
the pronunciation rules, not only the phonemes, but the way the phonemes flow together are different in different languages. So in our device, we have not only models of the phonemes, but we have the pronunciation rules as well.
So that sort of helps the sentence come out in context
That's
the
right.
way it might be if it were spoken.
With reasonably natural inflection.
Yeah, that's what I was going to ask. You said not only it recognizes the phonemes and then it massages those to turn it into normal speech. What do you mean by massaging it?
Well, what happens when you speak, you don't normally articulate everything. For instance, if you were giving instructions to someone, directions to someone, you would say, make a left turn at the corner. You don't say, make a left turn at the corner. So things are strung together in normal speech. And in fact, some sounds are not spoken at all in certain words. And there's rules for how you adjust the phonemes depending on what sound came first and what sound came afterwards. And also you need to know where the sound appears within a word and in fact where it appears within a sentence to make sure that you get the inflection properly.
Does manipulation of the phonemes also include volume and inflection, or is that done separately?
Yes, it includes the stress. It includes a phoneme isn't a fixed element. It starts at one point and it flows to another point depending on which sound comes next.
Carl, earlier when Herb and I were talking, we used the phrase speech synthesis, and that's different, isn't it, from speech coding? What's the difference, and what does this do?
Okay, the way to think of it is we call this synthesis by rule, because there is no pre-recorded speech or no stored speech in this device. It takes text and it produces speech according to the pronunciation rules of English. Okay, the other kind of speech, what people think of as speech synthesis, is synthesis by analysis, where the information is recorded from a human voice and then compressed or processed in some other manner by a computer so that it can be stored, and then it is simply reconstructed. There's no knowledge of what the words were, what they mean, or how they flow together. It's a sophisticated tape recording process, if you will.
Okay, Carl, I feel like there's been food on the plate, and I'm waiting for permission to eat it. Now, let's hear what this thing does.
Okay, let's. We created a few sentences before. We'll try one of those. Okay.
Describe what you're doing.
Okay,
as you punch it.
what I've done here is with this little keyboard, I've stored some messages ahead of time by typing them in, and here's one.
Hi Stuart, hi Herb. Thanks for the opportunity to appear on Computer Chronicles.
Okay, so now you had just typed that phrase in before on the keyboard.
That's right. I can type anything on this keyboard and it will then speak it.
Okay, now, again, going back to Herb's phone situation, are we looking actually at the thing you call call text?
That's right.
Now?
That's right.
Okay, now suppose I had an electronic message left for me in my computer, and could I then call it up on a telephone and ask the computer to read that file to me over the phone?
Exactly. That's
okay.
the
Could
basic...
you demonstrate something like that for me?
Sure. We have another message in here like that.
Stuart, we have rescheduled the taping to 4:30 this afternoon. See you then. Ron.
Okay, so that's a message from Ron. Again, if you were at your terminal to receive an electronic mail message, you could access that at your terminal. But if you were on the road and you stopped at a gas station and you wanted to find out what messages were left for you, you can call up a call text system and it will read your electronic mail to you over the phone. You made the point earlier, Herb, that there are many voice terminals in the world called telephones, but they don't hook up to a digital machine. Well, now they do, and you can in fact access any text database over the telephone in voice.
How large is the market for accessing databases via the telephone? Is that a new area that's just opening up, or a lot of people doing it?
Well, it's a new application. There are, at this point in time, there are no commercial online applications of that, though we are talking to most of the major electronic mail suppliers about the potential of this. Naturally, it's a new feature. The capability heretofore has not been available, and in fact the call text product line was introduced just at the end of last year, at the end of 1983, that is.
Carl, you played back a couple of messages which you had typed in earlier. I'd like you to actually type something in for me now so I can see how quickly you can turn a sentence into spoken speech.
What would you like to say?
Oh, just say we have about a minute left to do this.
Okay. We have a minute left to do that. We have, wait a minute, I'm in the wrong mode here. Excuse me just a moment. Okay. Now I have less than a minute, but we'll do it anyway. We have less than a minute to do this.
We have less than a minute to do this.
And it spoke very quickly. I appreciate that.
In fact, we can adjust the speaking rate also.
One last question before we have to take a break. Now, what is the product we're talking about? Is it this big blue box, or can I do something with my PC to accomplish this?
This is the product that's actually speaking. Okay, this board goes in an IBM personal computer, and this board contains the text-to-speech conversion equipment that's here. This is the microprocessor that is doing most of the controlling. It also has a telephone interface, which is the front end of the board, and in fact it has what's called an RS-232 port, which is the kind of port that you have on the back of a terminal. So in fact, this port, looking at a computer, looks like a terminal, and the computer thinks it's talking to a terminal. This port, you've probably seen that, looks like a telephone. So in fact, looking in from the telephone network, we have a telephone here, a computer terminal here, and the mechanism to convert text to speech in between.
We have to heed the
Okay.
computer's advice at the moment.
All right.
And in just a few seconds, matter of fact, we're going to take a look at a demonstration of speech recognition with a device that plugs into your, or in this case, our IBM PC. And that's coming up in just a moment.
Sales?
Which product line? Standard or deluxe?
Deluxe?
Earlier, we discussed the computer's ability to talk and listen. The correct terminology for these functions is computer voice response, CVR, for talking, and automatic speech recognition, ASR, for listening. Computer voice response uses two different techniques called waveform simulation and synthesis. Waveform simulation requires that someone speak the vocabulary into a microphone. The computer uses an analog-digital converter to digitize and store the words. When the computer wishes to give a voice response output, it retrieves the correct digitized word from storage and sends it to the awaiting listener through a digital to analog converter. In the CVR synthesis process, the computer digitally stores parts of word sounds, called phonemes, sort of an expanded set of phonetic ABCs. A sufficiently large vocabulary for most applications results from using about 100 phonemes. The needed phonemes are recalled from computer storage when needed, combined into proper words, and sent to the listener through a digital to analog converter. There is a great deal more sophisticated processing which takes place to give the proper inflection to the words and make them sound as natural as possible. The end result today is a very good approximation of human speech. The computer recognizes speech by digitizing words and comparing those patterns with stored patterns. The patterns will not match exactly because we don't always say words the same way. Consequently, the computer program must try for the closest match. This process works well for discrete words, but as mentioned earlier, word boundaries, large vocabularies, or speaking continuously present a problem. We'll see some speech recognition in our next segment. So let's get back to our program.
Joining us now is Ron Stevens. Ron is president and CEO of Votan. And Ron, we have a new piece of equipment up here now. Tell us what this is.
This box is the Votan V5000. It provides speech recognition and voice compression and playback facilities. It's connected over an RS-232 line with this IBM personal computer, and this is the color monitor that we have substituted for purposes of this demonstration for the normal monitor associated with the IBM PC.
Okay, run through a demonstration now and show us what this Votan unit does.
All right, the software package that's resident in the IBM PC is controlling this monitor, and I am going to illustrate the substitution of a microphone and my voice for the keyboard. So I'm going to control this program through the V5000 into the IBM PC and up to the screen with the microphone. Executive? Executive? Sales?
Which product line? Standard or deluxe?
Deluxe?
What channel? OEM, distribution, or total?
Total?
Would you like to compare to last year?
Yes.
Would you like to forecast for next year?
Yes.
We'll use 2 digits to indicate percentage growth over this year. Say the first digit.
2.
Say the second digit.
5.
The boss will never believe that. Let's keep it under 20%. Say the first digit.
1.
Say the second digit.
9. Exit. Exit. Telephone.
Who should I call?
Stockbroker.
Dialing.
There's a
Good
comment.
afternoon, ABC Brokerage. This is our computer information lookup system. You will be able to access information about your account by voice. At the sound of the tone,
Please enter your 3-digit access code, 1 digit at a time.
3, 5, 7.
Did you say 3, 5, 7?
Yes.
1 moment, please. Changes in your stock portfolio at the close of trading today. Amalgamated Widget up 2. You hold 2,000 shares. XYZ Corporation up 1/2. You hold 3,000 shares. Total gains in today's trading, $5,500. Would you like to leave a message for your broker?
Yes.
Start your message at the tone.
Buy 1,000 shares of Votan.
Would you like to hear your message?
Yes.
Buy 1,000 shares of Votan. Is this message okay?
Yes.
Your message has been sent. Thank you. Goodbye. Who
Exit.
should I call?
Exit. Exit.
That's pretty impressive.
Yes, it is.
First question I have, that speech is so good, it's hard to believe it's being generated by a computer. Now, what technology do you use to generate this speech?
Well, we use, the general class of technology that we use is the analysis and coding type of technology discussed earlier in the program. And the closest analogy to that is the digital speech that is often used in major telecommunications networks called pulse code modulation, which is 64,000 bits per second. Instead of using 64,000 bits per second of speech, however, we use something closer to 10,000 bits per second. So it is much more cost effective. In fact, it makes it feasible to use that type of speech in a computer system in the context of the costs of disk space and so on.
So you actually have someone speaking in a vocabulary, and you digitize that vocabulary at a sampling rate of around 10,000.
Yes, yes. And then store anywhere from 20 to 100, perhaps 200, or perhaps 1,000, depending on the application. 1,000 of those types of messages at locations or addresses within the computer that are accessible by the computer program.
And you're calling them out a message at a time, and that's why the message sounds like a message.
Yes. Now, you can call it out as a single message if the application calls for it, or you can string 2 or more messages together in sequence. For example, when this application confirmed my identification number as 357, that was really concatenated together, is the term used in the industry.
So we've really had examples of both of the technical approaches to speech synthesis.
Yes.
Can you say a little bit about where do we stand in the state of the art on the recognition side?
Well, there are several dimensions along which that technology can be analyzed. First of all, what I was demonstrating here was speaker-dependent recognition using discrete words. What we have available, and I could have demonstrated it here today if we had prepared for it, is speaker-independent recognition. Speaker-independent recognition is a notably more difficult technology, and one of the consequences of that is you normally have a comparatively more limited vocabulary. The other dimension along which the technology can be evaluated has to do with the distinction between discrete words and continuous words. We also have that available in the lab, and there are a few other vendors in the market supplying that. That allows you to say, instead of 1, 2, 3, 1, 2, 3, without pauses in between. The obvious question that jumps to most people's minds is, how soon will we have continuous speaker-independent recognition? And the answer is not soon. That's a few years out. The third dimension along which it's important to analyze the technology is the dimension of scale of vocabulary. Now, there is a fairly close parallel between the synthesis area in terms of a discrete or individual words pre-programmed, as we shown here, and what was demonstrated earlier by Carl in terms of, in essence, unlimited vocabulary. The technology for doing unlimited vocabulary speech recognition has been worked on for a number of years and is being worked on presently. Both ourselves as well as perhaps a dozen other people are working on that, and that is probably 2 to 4 years away.
Carl, I'd like to get you back in here. Tell us about the applications from your side, from the kind of, like call text, for example, as you showed us.
Well, the primary application of the call text is to access any text database invoice over the telephone. It not only is applicable to retrieving electronic mail messages, but for instance, a salesman in a customer's office can call in over the telephone into the database and retrieve that customer's order status, or perhaps the current inventory of a particular part, so that he knows that the customer can place that order in time.
Okay.
The important concept there is that
Quickly.
it doesn't require the intervention of an operator. It saves the cost of an operator.
As your computer told us about 10 minutes ago, we're out of time. Gentlemen, thanks so much for being here, and we'll see you again next week on the Computer Chronicles.
What makes a good computer speech application, and what's the prognosis for the future? Based on the current state of the art in computer speech understanding, not all applications are ready for talking computers. There are 3 considerations: feasibility, cost-effectiveness, and user acceptance. If the system requires too great a range of automatic speech recognition vocabulary, or too many individuals' input, then it may not be within today's technology. From a cost-effectiveness point of view, we must ensure sufficient hardware and software to handle the processing. The proper interface with telephones, for instance, and the need for backup if the internal or external communication system's down are important considerations. The last consideration is how the users will react if the transaction becomes too complicated. The future is promising for computer speech. The need is there, and the technology is improving rapidly. Some of the problems in language understanding are being actively researched in a field called artificial intelligence that we'll study in a future lesson. In our next lesson, we'll cover computers in education. Be sure and read Chapter 20 in your text, and I'll see you then. I'm Herb Luckner.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.